What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice graphing rational functions like the ones shown here. These are the first two examples we're going to go through. We're going to do 4 examples total, and everything will be time stamped. If you want to skip through, try some problems on your own, I definitely encourage that. Compare your strategy with my strategy and use this video to learn, check your solutions, that sort of thing. So let's go ahead and jump right into it, and I'll share my strategy, which is first gathering some information about the graph of this function. Right here are some features, and we're going to start with looking at the horizontal asymptote if one does exist. So with horizontal asymptotes, it's really about looking at the degree of the numerator and the degree of the denominator. So in this case, the degree of the numerator is 1, and the degree of the denominator is 2, because there are 2 factors, each with multiplicity 1. So in this case, the degree of the numerator is less than the degree of the denominator, and that means we're going to have a horizontal asymptote at y equals 0. So that's the horizontal line, y equals 0. That's a horizontal asymptote, where vertical asymptotes are going to be x equals some number because they are vertical lines. So vertical asymptotes we're going to find by focusing on the denominator of the rational function. And really what we're looking for are factors that are in the denominator but are not also in the numerator. Because if a factor is in both the denominator and the numerator, then it gives us a whole. So in this case, we have 2 factors in the denominator, and neither of these are also present in the numerator, so they're going to give us 2 vertical asymptotes. We're going to have 2 vertical asymptotes, one at x equals -2, because that's the number that makes this factor equal 0, and one at x equals 3, because that's the number that makes this factor equal 0. We have no wholes, since there are no factors that are present in the denominator and the numerator. But for example, if we had an x down here, then we would have a whole at 0, right? So that's what we're looking for. We're looking for wholes, factors in the denominator and the numerator. They give us 0 over 0 when we plug in something for x. And now we can look for x-intercepts. So in this case, we're thinking about, okay, well, when y is 0, right? So we can replace f of x with 0, and we can think about solutions to this equation, right? This rational function equals 0. So again, x-intercepts we get from plugging in 0 for y, solving for x, and really what we can do is look at the numerator and look for numbers that make the numerator equal 0 but that do not also make the denominator equal 0. So again, if I had x over x, for example, then there would be no x-intercepts. But in this case, since I have this x in the numerator and that factor is not also in the denominator, I do have an x-intercept, and it is at 0, 0, because that's what I have to plug in for x to get 0, right, to satisfy this equation. Awesome. Our y-intercept we can get by just plugging in 0 for x. This is perhaps the easiest one to get, right? I plug in 0 for x, I get 0 over 2 times -3, that's 0 over -6, which is 0. And I also could have just looked at the x-intercept and noticed, hey, wait a minute, the x-intercept is 0, 0, and that is also a y-intercept. That is actually the only point that is both an x and y-intercept, because it intersects both axes. So I'm going to go ahead and draw that point. I'm going to use blue to draw the graph, and I'm going to use purple for asymptotes. So we have a horizontal asymptote here. It's the line y equals 0, so it's going to be on top of the x-axis. So it's going to be a little bit hard to see, but I do have a purple dotted line here. And then we have 2 vertical asymptotes, one at -2. So I'm going to go ahead and do a dotted line going down here at x equals -2. This is a vertical line. This is a vertical asymptote. And then one at 3 as well. So I'm going to go ahead and do a dotted line going down here where x equals 3. And now this is really all the information we can put on our graph based on these features that we identified from our function here. We have a point that is both the x and y-intercept. We don't have any holes. We have all of our asymptotes plotted. And so from here, really the key to graphing these is having an understanding of what these asymptotes mean for our graph. So what these asymptotes mean, for example, let's focus on this asymptote here, this vertical one, x equals -2. What this means is that as our function, as the x values from the right get closer and closer to -2, the outputs of our function are going to get closer and closer to this line here, right? In other words, they're either going to shoot up to infinity like this, they're just going to keep getting bigger and bigger, and our function is going to get closer and closer to this vertical line, or they're going to go down here toward -infinity and just keep getting smaller and smaller, right? Those are really the 2 possibilities as we move from this point to the left toward this asymptote. So to figure out which of these 2 possibilities we have, what I like to do is just make a little table, and plug in values for x and figure out what those y values are, right? And actually in this case we can plug in -1, and all we really need to find out is whether -1 is positive or negative, right? If I plug in -1 and I get a positive output, that means I have a point somewhere up here above the x-axis, and that means the function has to be going up like this. If I plug in -1 and get something negative, it's got to be going down. So I'm really just going to plug in -1. And for y here, I'm just going to write whether it's positive or negative. So -1, I get a negative in the numerator, right? So I'm just writing signs here. -1 plus 2 is a positive in the denominator times -1 minus 3, which is a negative. I have two negatives here, right? A negative times a negative is a positive. A negative divided by a negative is a positive. And in general, anytime we have an even number of negatives in our rational expression here, it's going to give us a positive output. If we have an odd number, it's going to give us a negative, right? So I count two negatives here, so this is positive. So when I plug in -1 to this function, I get a positive output, which means the y value is positive, and we have to have this possibility where it's going up. It's above the x-axis. Hopefully that makes sense. We're going to do the same thing here with 2 to figure out what's going on from 0 to 3 here to this other vertical asymptote, because we can either have something like this where it's going up, or something like this where it's going down. Those are the only two possibilities, right? So we're going to figure it out. We're going to plug in 2. When I plug in 2, I get a positive in the numerator. I get 4, which is positive, times 2 minus 1, that is a negative. So here I have one negative, and that means my final output is negative, and that means this has to be the case here where we are going down. So I'll go ahead and erase this part up. We're going down as we go right. We're getting smaller and smaller, closer and closer to this asymptote. And that's how we do it. Notice we're sort of chunking this graph into sections. We have a section here to the left of this asymptote, between these two asymptotes, and to the right. And so we started on this one that's between these two asymptotes. Now let's move to the left here, this section that's circled. And this, again, is my strategy. We section off the graph and we do one section at a time. So here, again, knowing something about asymptotes, what could this section to the left of x equals -2 look like? Well, we know that this vertical asymptote means our curve is getting closer and closer to this vertical line. So this could happen like shooting up to infinity this way, or this could happen down here, right? And a horizontal asymptote is a very similar idea. As x gets smaller and smaller, as it gets closer and closer to negative infinity, the y values are going to get closer and closer to 0, right? So in this case, we could have something like this, and in this case, we could have something like this. These are really the two possibilities, the only two possibilities. We know there's no x-intercepts in this area, so it doesn't cross at all. So it's really these two possibilities, and to figure out which one it is, guess what we can do? Plug in a number. Plug in any x value that's in this section. I'm just going to choose, let's see, -3. I'm going to choose that. -3. Let's plug it in. We get -3 in the numerator. -3 plus 2 is -1 times -3 minus 3 is a negative as well. And so this gives us a negative, right? Because we have an odd number of negatives, which means this has to be the case down here. Hopefully that's making sense. We're going to do the same thing for this section. I'm going to plug in 1, 2, 3, 4. I'm going to plug in 4 because, again, there's only two cases. Either we do this or we do this. And again, this is a rough sketch. I am not an artist, but it's got to be one of these two types of curves, right? So I'm going to plug in, let's see, what did I say again? 4. I'm going to plug in 4. We get a positive in the numerator. We get a positive times a positive. So it's got to be the positive. I'm going to redraw this to make it look a little bit nicer. It's got to be up here. So here it's getting closer and closer to that line. It's getting bigger and bigger. And then here it's getting closer and closer to 0 from above. Draw our arrows here. Awesome. So that's the process that I use. First, identify all these features, draw all the asymptotes, plot any points that you know, section off the graph based on asymptotes, and plug in numbers to figure out what's going on with the graph. Use your knowledge of asymptotes to limit the possibilities so that you can just plug in a number and boom, draw a whole section. So let's check what we have here with Desmos, and it's looking pretty good. Again, we're just sketching these. It's not going to be exact, but it's looking pretty good. We're getting a good general idea of what these look like. So let's try another example. This is example 2, and in this case, you can pause the video and try this on your own. The thing I recommend to do first is definitely to factor the numerator and the denominator. Notice the last one was given in factored form, and this one is not. So anytime we have something not in factored form, we just want to go ahead and factor the numerator and denominator. So the numerator is a difference of squares. And I'm going pretty fast here factoring because I'm assuming if you're graphing rational equations, you probably are pretty good at factoring. So I'm going to go pretty quick. The denominator we can factor. This is a trinomial, a equals 1. I'm just looking for two numbers that multiply to -6 and add to +1, and I believe that's going to be 3 and -2. Alright, so now let's go into finding our horizontal asymptote, vertical asymptote, all these different features. So I'm going to do this in red. In this case, the degree of the numerator is equal to the degree of the denominator. Whenever that happens, the horizontal asymptote does exist. We do have a horizontal asymptote. And its equation is the ratio of the leading coefficient. So we take the leading coefficient of the numerator over the leading coefficient of the denominator, and that fraction is the equation for our horizontal asymptote. So in this case, we just have 1 and 1. So our horizontal asymptote is the line y equals 1. Vertical asymptote. So again, we are looking for numbers that make the denominator 0, but that do not also make the numerator 0, because that would give us a whole. So notice here I see a factor of x minus 2 in both the numerator and the denominator. That's going to give us a whole. That means there is a whole where x equals 2. And as a point, we can figure out what exactly this is. We'll come back to this in just a second, right? Because a whole is a point on the graph. We're going to figure out that y value. Let's go back and finish the vertical asymptote. This x plus 3 is a factor that's not present in the numerator. And so this does in fact give us a vertical asymptote. Since the number that makes this factor equal 0 is -3, the vertical asymptote is the line x equals -3. Okay? So for me, it would be acceptable to write at x equals 2, right, if you're just trying to identifying the whole, but since we're trying to graph this, we want to actually plot the whole on our graph, so we need a point. We need a y value here. So here's the trick. Here's how we find the y value for the whole, is we plug 2 into the function, but we plug it into this sort of simplified version, right? So we ignore these two x minus 2 factors, and we plug 2 in, and whatever we get as an output, that's our y value. That's the y value of the whole. So when we plug in 2, we get 4 in the numerator and 5 in the denominator. So we have a whole at 2, 4/5. That's the point of our whole, and we'll be able to graph that. Hopefully that makes sense. To find the y value of the whole, we take the x value that we get from the factor that's present in both the numerator and denominator, and we plug it into the simplified version of the function without those two factors. X-intercepts. All right, now we are looking at the numerator, and we are looking for numbers that make the numerator equal 0, but that don't also make the denominator equal 0. So I kind of like that I already canceled these two factors, because now I can ignore them. There's definitely not an x-intercept there because there's a whole at 2, so that can't be an x-intercept. So the only x-intercept is at -2, and we can write that as a point. When I plug -2 into this function, I get 0. So there's a point at -2, 0. For y-intercept, we just plug 0 into the function. And here's a quick trick that I like to use for the y-intercept. I always go back to the function before we factored it, right? Because then what we can do is we can imagine plugging 0 into the function, and we can just ignore any term with an x, and we can see that we're left with -4 over -6. Hopefully that makes sense. I like going back to this instead of trying to plug 0 into here. I don't know, maybe it's a little bit easier, maybe not. If you plug it in here, you still get 2/3, but that's just my preference a lot of the time. A lot of the time it ends up easier. So we do get 2/3, right? Because -4 over -6 simplifies to 2/3. We can also see it here, 0 plus 2, 0 plus 3. All right, we have a lot of information here. I'm going to go back and use purple again to do asymptotes. This time our horizontal asymptote is at y equals 1. So let me go ahead and write a horizontal line here. We have a vertical asymptote at x equals -3. So I'm going to do a vertical asymptote there. All right, what else do we have? I'm going to use blue for like function values. So -2, 0. So when x is -2, y is 0. That's a point here. That is our x-intercept. And then when x is 0, y is 2/3. So that is a point right about here. And then what else do we have? We have a whole at 2 4/5. So when I go to 2 and I go to 4/5, there's like a little open hole here. I'm going to draw that. Okay. I think I have a pretty good idea of what this function looks like to the right of this line, x equals -3. Again, we're always thinking about sections. We really only have two sections here, this one and this one. These sections are sort of separated by these asymptotes, right? So I'm going to first focus on the section to the right, because I am pretty confident that what happens, and hopefully it's clear, is that we can connect these 2 points. We know that our function has to just jump over this hole so we can connect there. And then our function just keeps going. It gets closer and closer to this horizontal asymptote, right? And in this direction, hopefully it's going to make sense that the function is going to go down and down and get closer to this vertical asymptote. And if you really wanted to check, maybe you're thinking, hey, maybe it does something like this and it bounces off and goes up, right? I mean, that would be, it looks a little weird, but who knows? Sometimes weird stuff happens in math. You could absolutely plug in, let's see, -1, -2, -2.5, and you could make sure that the output is in fact negative. In this case, it will be -2.5 plus 2. That gives us a negative, and then the denominator we get a positive, right? So we can confirm that again by plugging in points, and you can make an official table if you want. That's totally fine. We're definitely going to need a table to the left here, right? Because what I see are two possibilities. Again, we know our function gets closer and closer to these vertical asymptotes. So it's either getting closer from above or from below. And we know the same thing happens here. It gets closer and closer to the horizontal asymptote. And so it either gets closer this way or this way. And so one thing we could do is we could absolutely plug in a point and we can figure out what is going on with the y values of this function. We could plug in -1, 2, 3, let's see, -4, -5, any of these numbers and figure out where is the y value. But I think actually we can narrow down which of these two possibilities is the case just from our knowledge of this function. And let me be more specific here. If this were the case, if the function came down towards infinity in this way and got closer here, and then we went up and we got closer and closer to this horizontal line this way, for this to be the case, the function would have to intersect the x-axis somewhere around here, right? And we know there is only one x-intercept, and we already plotted that. So we can actually eliminate this from being the case just by knowing that the function does not have an x-intercept anywhere in this section to the left of this asymptote. And if you don't notice that, that's totally fine. You could also just plug in a number, right? Let's say we plug in -5. And you could even find the exact y value if you want, if you really want to be precise. You could plug in -5 and you get what? -3 over -5 plus 3 is -2. And so you get what? It's 3/2. And so you can go here to -1, 2, 3, 4, 5, go up to 3/2, plot a point there, and then absolutely connect that point within your graph here. Go down here, and then get closer and closer to the left. Sorry, it's looking a little janky, but that's the idea. And we're going to erase this. We'll keep our final product here. And that is about as good as it's going to get for me, not being an artist. And we can double check our answer here. Let's pull up Desmos. But hopefully that process makes sense, as we can again use our knowledge of how many asymptotes this function has and where the asymptotes are to sketch this graph. So let's go to Desmos here. This was our previous graph. This is our new graph. It's looking pretty good. Okay, so again, we can always double check our answer when we're practicing by using Desmos. Let's jump to the next example. In this example, I encourage you to pause here. Really try this on your own. Pause the video, write this out, factor this, identify all these different features, draw a coordinate plane, write out your asymptotes, your holes, your intercepts, and then try to investigate and figure out what this function looks like. You can skip ahead and check your answer, but really practice trying this on your own. Math is not a spectator sport. You get better by doing it, so try it. Awesome. Hopefully you have an answer and you're just comparing your answer with mine. I'm going to factor out a 2, and then I'm going to be left with x squared minus 1, which is a difference of squares. So in the numerator, I'm just going to go ahead and erase this so I have plenty of room. The numerator is going to become 2 times x minus 1 times x plus 1. Denominator, again, I have a pretty straightforward trinomial, two numbers that multiply to -6. But add to -1, that's going to be -3 and plus 2. Awesome. All right, so now I'm ready to find my horizontal asymptote. And in this case, again, the numerator and the denominator are both of degree 2, same degree. So our horizontal asymptote is the line y equals, and we take the fraction where the numerator is the leading coefficient of the numerator, and the denominator is the leading coefficient of the denominator. So 2 over 1. So it's the line y equals 2, right? The ratio of the leading coefficients. Vertical asymptotes, we're looking at factors in the denominator that aren't also in the numerator. Neither of these factors, x minus 3 or x plus 2, are also in the numerator. So both of these give us vertical asymptotes. So we have vertical asymptote at 3, because that makes x minus 3 equal 0, and at negative 2, because that makes x plus 2 equal 0. Now our whole, we have no wholes, right? There are no factors in the denominator that are also in the numerator. We don't have the 0 over 0 situation that's possible, so no wholes. Let's look at x-intercepts. We have two values that will make the numerator equal 0, 1 and negative 1. And neither of these values also make the denominator equal 0. So we have two x-intercepts, one at 1 and one at negative 1. Y-intercept, we can plug in 0 for x and see what we get for y. And again, I like to go back to this form here. When I plug in 0, that's 0, that's 0, that's 0. We have negative 2 over negative 6, which is 1/3. So in this case, I think it actually was, in fact, easier to go back to that unfactored form, right? Awesome. All right, we have all the information we need. Let's see, what have I been doing? Purple for asymptote. So I'm going to go up here to y equals 2, do a dotted line. At y equals 2, at x equals 3, same thing. Going to do a dotted line here. At x equals negative 2, same thing, dotted line. Awesome. All right, now what do we have? No wholes, so we have intercepts. So these are actually on the function. I'm going to use blue. So when x is 1, y is 0, that's a point. When x is negative 1, y is 0, that's a point. And then we have another point here at 0, 1/3. Awesome. All right, that's all we have. But I think based on this, I have a pretty good idea of what's going on in this middle section here. Again, I'm thinking of this graph in sections, left, middle, right. I'm going to start with this middle because I think it's pretty clear that the graph connects here, and then goes down in both directions, right? Goes down here, gets closer and closer to that negative 2 vertical line, and here gets closer and closer to that vertical line, x equals 3. Again, if you're in doubt, what can you do? You can plug in 2 into the function. Make sure you get a negative output, right? You can plug in, well, this one's a little trickier. Let's see, negative 1.5, and make sure you get a negative output. So I'll go ahead and make a table here, and I'll just try one of those. I won't try both. You can try both if you want. I'll try the harder one, the fraction, the negative 1.5, or decimal rather, right? Okay, so when I plug that in, I get what? 2, that's a positive. I'm just going to ignore that, times, let's see, negative 2.5 times a negative, right? Negative 1/2, and then another negative, and then times a positive. So there are 3 negatives. So the final result is in fact negative. And so that confirms that from here to the left we are going down. And you can do the same thing. Try plugging in 2, making sure you get a negative as well. Awesome. All right, now we have these 2 other sections. And I think I can use similar reasoning that I used in the last example to conclude that each of these sections has to be above the horizontal asymptote. That this section has to do this, and that this section has to do this. And why is that the case? Well, because I'm thinking about what is the other option, and that's that it does this, and goes up and gets closer and closer to this line, and for that to be the case, we would have to have an x-intercept within this section of x values, which we don't. We've already found all the x-intercepts, and they're all in the middle. So this cannot be the case. Let's say you're taking a test, you want to figure out for sure, you want to 100% confirm that this is what the graph looks like. So let's go ahead and try. Let's plug in, let's see, negative 1, 2, negative 3 here. Let's plug that in for x and see what y value we get and make sure that it's something bigger than 2 above this horizontal asymptote. So let's try plugging in negative 3. And in this time, I'm going to get an exact value here. I'm going to try to get a point. So I have 2 times negative 3 minus 1, that's negative 4. Times negative 3 plus 1, that's negative 2. And then in the denominator, I have negative 3 minus 3, that's negative 6. Times negative 3 plus 2, that's negative 1. Okay, so this is my point. Obviously, I want to simplify it. I want to figure out what this is. We have, let's see, 2, 4, 16. That's positive 16 over positive 6, which is what, approximately? A little bit bigger than 2. So as a mixed number, how could I write this? Negative 3 and 2 and 2/3, 2 and 4/6, 2 and 2/3. So negative 3, I can go 1, 2, 3, and then a little bit above 2 right here, 2 2/3. So I can even adjust my graph a little bit because in fact it gets a lot closer to this line a lot quicker than I have represented here, right? So I can adjust my graph. Again, for the test, I do not care. The general shape is fine. We are just sketching. We're really trying to figure out what this graph is doing in each of these sections, whether it's above, below, going up, going down, that sort of thing. But this is a great way to double check your work, get really precise if you want to. Let's try our last example now. Alright, so here's our last example, and at this point I definitely encourage pausing the video and trying this one. This is the hardest example we've done yet. So let's go ahead and start. Horizontal asymptote. We already have this in factored form. The degree of the numerator is 2. The degree of the denominator is 2. They are the same. So the horizontal asymptote is the ratio of the leading coefficients. We have a negative here, and we have nothing here, so it's like a little invisible 1. And negative 1 over 1 is negative 1. So it's y equals negative 1 is the equation of the horizontal asymptote. Vertical asymptote, we're looking at the denominator. What are factors that are not also present in the numerator? Well, both of these, x and x minus 2. So this gives us 2 vertical asymptotes, one at 0 and one at positive 2. And again, there are no holes because there are no factors in the denominator that are also in the numerator that would cancel and give us 0 over 0, right? So no holes. X-intercept, so there's two numbers that make the numerator equal to 0, and neither of these also make the denominator 0. Those numbers are 3 and negative 3. And for our y-intercept, we're thinking about plugging in 0 and seeing what we get for y. And in this case, when we plug in 0, what do we get? Well, we get 0 in the denominator, right? It is undefined. So in this case, there's actually no y-intercept. We're going to write none, which makes sense because there's a vertical asymptote at x equals 0, which is on the y-axis, right? So there can't be a y-intercept. Hopefully that makes sense. Let's do our dotted lines here. Y equals negative 1. There's our horizontal asymptote. X equals 0, that's a vertical line that's on the y-axis here. X equals 2, that's a vertical line that's here. And what else do we have? We have a couple of points. Let's see, I'll use blue for those. So we have negative 3, 0. That is a point on this graph. And we have 3, 0. All right. So again, we have 3 sections here because we have 2 asymptotes. We have this far left section, this in-between section, and this right section. So I actually like to start with this in-between because this is kind of tricky. There are no points in here. We don't have much of an idea of what's going on in here. But actually we kind of do because based on the fact that there's no x-intercept here, that actually tells us something. It tells us that we either have to go up in both directions, like something like this, or we have to go down in both directions, something like this. Why is that? Well, if we went up in one direction and down in the other, then it would have to cross the x-axis somewhere. And for that to be the case, it would have to have an x-intercept here, and we know it doesn't. So it's got to be one of these two. How do we figure out which one? Well, we can make a little table, plug in a point. I'm going to plug in 1. That's kind of the obvious point to plug in, right? So I'm going to come to this table, write in x and y, plug in 1. And actually this time I'm going to get an exact value. I just want to see what this point exactly is. Of course, to narrow it down between these two options, you could just figure out whether it's positive or negative. But I'm going to go ahead and plug it in exactly and be precise. Not required on a test, but I'm just doing it for funsies. So let's see, we get 4, so negative 2, 4. Then we get 1 times 1 minus 2, which is negative 1. Okay, we have 1, 2, 3 negatives. So our final answer is definitely negative. And then what is it? 2 times 4 over 1, so negative 8. So when I plug in 1, I get negative 8. And so that means we have this shape down here. And in fact, it's a lot lower than I have shown here. So I can adjust for that, just make our graph a little bit more precise. Again, since we're just sketching these, at least that's what I'm requiring. Totally not required to do this, but it starts kind of low like this, and we're going down in both directions, getting closer and closer to the asymptote on both sides. Awesome. Hopefully that makes sense. Now let's work on one of these sections. We can go to this section on the left. Okay, so we do have an intercept here. We know this curve is going to get closer and closer to the vertical asymptote, so it could do something like this, or it could do something like this, right? So which of these two things does it do? Well, let's see. I feel like it does this, and here's why. If it does this, then it crosses at this point and gets closer and closer to the horizontal asymptote, which we know is also the case, right? If it did the other thing, if it went down like this, then it would have to, like, it can't cross here, because then it would have to cross again, and that's not possible, because there would be another x-intercept. It would have to, like, bounce, and that seems kind of weird. I don't know. I don't think it does that. But how can we find out for sure? Let's plug in a point. So let's plug in a point, -1, 2, 3, -4. I'm going to plug in -4. If -4 gives me a negative output, then we know this has to be the case, right? Because this shows a negative y value corresponding to the x value -4, right? So this has to be the case, and then we're going up like this. If -4 gives me a positive, then I was wrong. My suspicion is wrong, and it's the other way. But I'm pretty sure this is this way. Let's just double check. So I'm going to plug in -4 here. I already have a negative times -4 minus 3, that's a negative, times -4 plus 3, that's also a negative, over a negative times a negative, 5 negatives. So this is in fact a negative. My suspicion's correct. And maybe you're saying, well, what about this? What if it bounces and does this? Well, sure, we can confirm that as well. We can plug in 2 and make sure it gives us a positive. We already have a negative. That gives us a negative. That gives us a positive. Then we have a positive. I meant to plug in -2. Uh-oh. Is that what I've been doing? -2 plus 3. Yes, that is what I've been doing. Awesome. This is a negative, and then that's a negative. We have 4 negatives. That does give us a positive. So our suspicion was correct all along. This is the case that we have on this left section. And now we can move to this right section, and I have a feeling a similar thing is going to happen, where it's going to go down and get closer and closer to this horizontal asymptote, and to the left it's going to go up. And so we can plug in some points to double check. So I can plug in 4, for example, and make sure it gives me a negative output. What does 4 give me? Well, there's already a negative there, times 4 minus 3, that is a positive, times a positive, that's 4 plus 3, over a positive times a positive. So that does in fact give me a negative, and I could plug in 2.5, and I would see that would give me a positive, and this graph is correct. Awesome. Hopefully this video helped and made sense. Again, we can double check all of these on Desmos, compare our graphs with the very precise graph that Desmos gives us. Hopefully this makes sense. Leave comments if you have any questions, and I'll see y'all next time.